Recording. So here we were on the segment addition postulate, and we went ahead, we did do this problem that's at the bottom as well. So segment addition postulate basically says if you have a segment that's divided into two pieces by a point, well, you can set up an equation based on the lengths of these segments. The two smaller pieces add together to make up the whole segment. And that's kind of what it is in words right there. So we're going to use this a lot. We're going to use the segment addition postulate to set up equations about segments and solve to figure out segment lengths or maybe just the value of x. It's going to be a common type of problem that we need to feel pretty comfortable with. All right. Yeah, math teachers suck. They just have to throw algebra into everything. All right, so there's a special point that's between two given points. It's called the midpoint. It's the point that's exactly in the middle. The midpoint is going to divide the segment into two congruent parts. Another way that we're going to say something is the midpoint is we might use this word bisect. A midpoint bisects a segment. The word bisect just means to divide into two congruent parts. Just generically, we'll use bisect to talk about a lot of different things, not just segments. So really quick. If you have a segment, we'll call it A, B. So these are our segments. The midpoint is going to be exactly in the middle. So I'll estimate that to be about there. We'll call this our midpoint. On a diagram, on a picture, without us saying that this is the midpoint, there might be some symbols on here, might be some notation on the picture to help us know that. If we see tick marks like this, which means that this segment here from A to M is congruent to this segment here because it has the same tick mark, that would help us know that this is the midpoint. Another way we might say it, we might say something like M bisects AB, the segment AB. So in words, we might say something like that. Or we might just say M is the midpoint of AB. Midpoint of AB. There are kind of three different ways we might figure out that we have a midpoint. It might be shown on the picture with these congruent markings. We might say that the point bisects the segment, or we might just out and say that M is the midpoint. All three of those ways are going to be pretty common, but different ways for us to talk about a midpoint. Segment bisector, that's another way that we can do this. A segment bisector is, well, anything that cuts a segment into two equal parts. If it is bisecting a segment, it's going to cut that segment into two equal parts. Now, anything can really be a segment bisector. Again, if I just have a segment of some kind, I could have just a point there, right? That point could be considered a segment bisector. I could have another segment that just touches it right there. That could just be a segment. This could be a ray, and it could cut the segment in half. We could call that a bisector, or it could just be a whole line altogether, and that could be considered a segment bisector as well. Anything that's taking the segment that we start off with and cutting it into two equal parts. All those things can be considered a bisector. So, including, you know, anything, 75 Coupe de Ville, that's a car, a Cadillac, right? Anything that cuts our segment into two equal parts, that passes through the midpoint in some way, or is the midpoint, we would call that, we would refer to that as a segment bisector, because that's what it's doing. It's bisecting our segment. So the homework for this section is this, 1.2. You've probably already seen this if you've been kind of glancing around on the Google Classroom page. I'm going to do a couple other problems after this, so this isn't quite the end, but just make sure we know that The expectation is you try to do as many of these as you can, you know, and get help with them if you need to. If you need to come into the office hours today at 1:30 or Wednesday at 1:30, or email me for some questions or something, you can do that. Problem number 30, that's the one you need to do thoroughly, take a picture of, and attach to the Google Classroom assignment. Just that one. And that's the one I'm going to give you actual feedback on and grade you on as a homework assignment. All right. I'm going to stop my share for a second, and I'm going to share just a whiteboard so I can do this. So there's so many types of problems that go on that involve the segment addition postulate or involve midpoints. Sometimes we're going to have a picture, sometimes we're not going to have a picture. We kind of have to take the given information that we're starting off with and figure out what we need to do. So we might be given a problem like M is the midpoint of AB. And then we might just be given some information like AM equals 2x plus 7 and AB equals, I don't know, 48. So if we get something like this without any picture, we're gonna have to take all these words. Well, we might not have to. You might be able to visualize everything in your head at the same time, set up the relationship, whatever, but I would recommend trying to make a picture. So just kind of starting off here, I want to make a picture of just a midpoint. So I prefer to do this. I prefer to make a picture and label it, just so I can wrap my head around everything. And as they get more complicated, they might be helpful. All right, so we have a segment 8, and M is the midpoint. Okay, so I've got a picture. I'll go ahead and label that. I'll make sure that I know it's the midpoint with those congruent markings. And then the other thing is I'm going to take our given information and I'm going to kind of label my picture. So AM is 2x plus 7. And the whole thing, AB, is 48. All right. So now I need to figure out what sort of thing I could use. With midpoints, anytime you have the midpoint, you know that these two are equal. So you know that in this problem, AM would be equal to MB. That's one relationship I could use to set up an equation. But in this case, I don't think that's really helpful. One, I don't know how big MB is. I don't even have an expression for it at the moment. And that's just not going to be helpful. So that's kind of our midpoint relationship, that the two segments are equal. But the other thing we know is based on the segment addition postulate, we know that if we do AM plus MB, right, those two pieces, that has to equal the whole thing, which would be AB. So I can use this to set an equation this time, except again, for this problem, I don't know what MB is. Does anybody have any ideas how I could get around that? What could I use for MB? Feel free to.
If AM is equal to MB and AM equals 2x plus 7, then shouldn't MB equal 2x plus 7?
Exactly, yeah. So since I know that I have a midpoint, and that means that these two segments are equal, that means that I could just go ahead and label this to be 2x plus 7 as well. And now I have something that I could put in for all of these things. This is one way to do it. Another way to do it is, again, thinking about midpoint. Since M is the midpoint and my whole length is 48, half of it, which is this half, would have to be equal to 24. So again, I could use midpoint ideas. There's not necessarily one way to go about solving this. I could do it that way as well. But I'm going to use the segment addition postulate way this time. But again, a lot of these problems have multiple ways of going about and solving them. All right, so we know that AM is 2x plus 7 plus MB, which is the same length because they're equal, and they equal 48. But again, if they're the same and they add together to be 48, then one of them is going to be half of 48, but that's okay. Adding these together. I don't know why I did that. Subtracting 14. $34, and then divide by 4. And that is going to be 8.5. Now, this particular problem, I didn't ask to find anything, which is kind of silly. I should have actually asked a question here. For this problem, I more or less just gave setup information, but there are many questions I could ask. I could ask us just to solve for x, right? And we could be done. We could say, all right, cool, that's my answer, solve for x. I could ask to find one of the lengths. I could ask us to find like AM or MB or AB. We could figure out what all of those lengths are now that we know X. Well, I guess we already knew AB was 48. So that one we wouldn't need to do anything because that was given to us. But I could figure out one of these and get that answer too. So there's a lot of different questions that could be asked. So just make sure when we are presented with a question, you're reading carefully about what the final answer needs to be. Do I just need to know what X is equal to? We'll go ahead and set up the equation and solve for X. Do I need to figure out an actual segment length? In those cases, I might need to take the value that I solved for and substitute it back in, right? Varying types of questions that we might see here. So looks like we have about 4 more minutes. So I'm gonna go ahead and clear all this and stop for a second. I'm gonna stop my share again. So we've kind of gone over all the things, though it's kind of impossible to go over every single application or type of problem that might come up. That's where the homework's going to come in. It's going to take these ideas of the segment addition postulate and midpoint and try to let us work with different types of problems. When you start with a problem, I really recommend, if there isn't a picture depicting the situation, to try to draw yourself a picture that shows the situation accurately. Label that picture, and then once you have a picture, it's a lot easier to visualize the relationship, the segment addition relationship or the midpoint relationship that's going on there, right? So if you're running into those situations, make sure that you have a picture and that you've labeled a picture. All right, 3 more minutes. Does anyone have any homework questions for me?